Hey everybody, Mr. Cruze here. Welcome back to another Algebra 2 review walkthrough. In this video, I will be doing the first part of the Chapter 6 test review. Remember, your test tomorrow is over the first 5 sections of Chapter 6, which has a lot of radical expressions and equations. And remember, there are a lot of rules that you have to keep track of. That's what makes this so difficult, is there are a lot of rules that you have to keep straight. So, let's begin. Your instructions will say simplify or rationalize the denominator. Remember to use absolute values when necessary. When do we use absolute values? When we have an even index and we get an odd power answer. So something like square root of x squared, well, that would be x, but you need absolute value because it's x to the first. It came out to be an odd power from an even index. Okay? So star that and make sure you know that. Alright, number 1, square root of negative 1 over 121. Well, we're trying to simplify this. Can I take the square root of a negative number? And the answer is no. So this is no real root. You cannot take the square root of a negative. Okay? Number 2, however, you can take the cubed root, or any even root for that matter, of a negative. I know that the cubed root of positive 27 is 3, so that means the cubed root of negative 27 is negative 3. Okay. Number 3 here, we have 2 times the cubed root of 2xy squared times the cubed root of 4x squared y to the 5th. Multiply to begin with. Any numbers outside get multiplied together. That's just a 2. Any numbers on the inside get multiplied together. 2 times 4 is 8. X times x squared is x to the 3rd. Y squared times y to the 5th is y to the 7th. Okay. Now we have to break down the radical. The 2 stays out front. Does not go anywhere. We're breaking down the radical into a perfect cube and what's left over. So, 8. What's the largest perfect cube that divides into 8? Well, that would be 8 itself, with nothing left over. X cubed, well, that's a perfect cube in itself, so it goes over here, with no x's left over. The only thing is the y to the 7th. So think about your largest perfect cube that would go into y to the 7th. That would be y to the 3rd, y to the 6th. Y to the 9th would be too big, so it's y to the 6th with one y left over because it has to multiply back over to y to the 7th. That's where we seem to have the most troubles with those variables. Okay? Think about it like this. It's a recipe, right? You need 3 of everything to get it out. You can pull out 3, you can pull out another 3, so that'd be a total of 6. But you try to pull out 3 more, you can't. You only have 1 left. All right? So, 2. Cubed root of 8 is another 2. Cubed root of x cubed, you take the power divided by the index, and you get x to the 1st, y to the 6 over 3, which is 2, and then the cubed root of y. And your only thing that you have to take care of now is 2 times 2, which is 4. Do I need absolute value? No, because this is an odd index. I don't have to worry about even index. Okay. Square root of 192 over the square root of 3. To start off, anytime you have these division problems, you're going to want to divide, okay? Reduce what you can. Well, 3 goes into itself once, so I get square root of 1 on the bottom. Square root of 192, if I divide it by 3, you get 64. Well, hey, this is just square root of 64. And that's just 8. Pretty straightforward, right? All right, 4th root of 81 x to the 8th y to the 10th. Okay, so let's break this up. What's the largest perfect fourth that goes into 81? Well, that's 81 itself. Remember, you'll have your list tomorrow, right? Largest perfect fourth that goes into x to the 8th, that'd be x to the 8th itself. Nothing left over. And y to the 10th, well, I could pull over y to the 8th, which will leave me with y squared behind, okay? 4th root of 81 is, of course, 3. 4th root of x to the 8th is x squared. 4th root of y to the 8th is y squared. And we have the 4th root of y squared. Okay, no absolute values necessary there. Okay, so number 6, we have the 4th root of 9 times the 4th root of negative 9. Uh-oh, 4th root of negative 9. You can't do that. You can't take even roots of negative numbers. So even if you tried to multiply those together, you still couldn't even take the 4th root of negative 81. It wouldn't work. So this is no real roots again. Okay, so be on the lookout for that. All right. Adding and subtracting radicals. Make sure they're the same radical, identical, both index and radicand. Okay? Make sure everything about it is exactly the same. So, let's break some things down here. Square root of 75 breaks down into the square root of 25 times the square root of 3. Don't forget the 3 is still out front. So this becomes 3 times 5 square root of 3. So this is the same as this, 15 square root of 3. Okay. Now, 2 square root of 8 minus 1 square root of 8. You can go ahead and actually simplify that. This becomes plus 1 square root of 8, right? 2 minus 1. Since those are the same, you can go ahead and add those. But square root of 8 does indeed break down into the square root of 4 times the square root of 2. So it's plus 2 square root of 2. Cannot add these. Even if you tried, what would you do with radicals? You couldn't combine them, so that's it. Okay. Number 8, remember, same radicals. Are these the same? No. So you put either cannot combine, or you can just rewrite the problem. I will take either answer. Doesn't matter to me. Both of those work. You can't combine those. Okay. Number 9, once again, you have to reduce what you can. And this one's arguably easier than the day 1 review, because when you reduce 60 and 5, we're just left with 12 over 1. X to the 24th over x to the 3rd leaves you with x to the 21st up top and nothing in the bottom really. So the bottom goes away completely. You're just left with square root of 12x to the 21st, and you just have to break that down. Let's see. Square root of 12 breaks down into 4 and 3. X to the 21st, what's the largest perfect square? Well, that would be x to the 20th with 1x left over. So you get 2x to the 10th, square root of 3x. No absolute values necessary because that came out to be an even power for x. So far, so good. Number 10, let's see. This is FOIL, basically. No different than 7 minus x times 4 plus x, right? No different. You're just multiplying, okay? 7 times 4 is 28. 7 times square root of 11 is plus 7 square root of 11. Negative square root of 11 times 4 is negative 4 square root of 11. And negative square root of 11 times positive square root of 11 is negative square root of 121. Okay, be careful about the negative. Well, I know what negative 11, or negative square root of 121 is. I just told you the answer. It's negative 11. So 28 minus 11 is 17. 7 square root of 11 minus 4 square root of 11 is plus 3 square root of 11. And that's all you can do. Okay. The next one's rationalizing the denominator. Since it's square root of 13 in the bottom, I'm going to multiply by the square root of 13 on the top and the bottom. That way the bottom becomes the square root of 169. And we can actually take the square root of that. And we'll get rid of any radicals in the denominator. That's the goal of this problem. Here you distribute. Make sure this goes to both places. Square root of 9 times the square root of 13. Well, it might actually be easier for this one. Square root of 9 was actually 3, right? So this will be 3 square root of 13 plus the square root of 13z. Okay. And the only other thing is the bottom. 3 square root of 13 plus the square root of 13z all over 13. And you might think, can I reduce anything, cancel anything out? Not here. That's it. Make sure your answer circle doesn't clip through your square root. That's it. Cubed root of 7 over the cubed root of 2. Again, rationalizing the denominator. Only this one's a cubed root, which means I need 3 of everything to get out. Currently, this is 2 to the 1st. So how many more 2's do I need? 2 more. 2 squared. Okay. The top, well, of course we know 2 squared is 4. 4 times 7, so this will be the cubed root of 28 over the cubed root of 2 times 4, which is 8. If you look on your table, the cubed root of 8 is 2. And then you can look and see, does the cubed root of 28 break down? No, 8 doesn't work, 27 doesn't work, and by that point you're too big. So this is it, the cubed root of 28 over 2. Last one I'll do for this video, 3 minus the square root of 7 over 2 plus the square root of 7. All you would do, this one's a little different. You can't just multiply by square root of 7 like you could in number 11. Okay. This time you have to multiply by the conjugate. Okay. And conjugate's really simple to get. See on the bottom how it's 2 plus the square root of 7? Its conjugate will be the opposite of that, 2 minus the square root of 7. Whatever you multiply the bottom by, you have to do to the top as well. Okay? And then it's a giant FOIL problem. Okay? So make sure that you do all that. 3 times 2 is 6. 3 times negative square root of 7 is negative 3 square root of 7. Negative square root of 7 times 2 is negative 2 square root of 7. And negative square root of 7 times negative square root of 7 is positive square root of 49. We'll deal with that in a second. On the bottom, 2 times 2 is 4. 2 times negative square root of 7 is negative 2 square root of 7. Square root of 7 times 2 is 2 square root of 7. And square root of 7 minus square root of 7 is negative, or times negative square root of 7 is negative square root of 49. So that's multiplying. Once again, square root of 49 is 7, so be careful. And look at the bottom here. These two middle terms cancel each other out. They're gone. That's what we wanted to happen. There will be no square roots left over. So 6 plus 7 is 13. 6 plus 7. Negative 3 square root of 7 minus 2 square root of 7 is minus 5 square root of 7 over 4 minus 7. Okay. Anyway, you get 13 minus 5 square root of 7 over negative 3, and that would be just fine with me. If you put negative 13 plus 5 square root of 7 over 3, either answer would be the same. I'd be okay. Wouldn't matter to me. Okay.